Here's another example of solving a radical equation. So this time we have 2 times the square root of x plus 2 minus 2x equals 4. So the very first thing that we do, like always when we solve radical equations, is get the radical by itself on one side, put everything else on the other side. So the very first thing we want to do then is add 2x to both sides. So that's going to give us 2 times the square root of x plus 2. And then since we add 2x to both sides, we get 2x plus 4 on the right-hand side. Okay. Now from here, there are actually a couple different things we could do. One is right now we could square both sides. Okay, so if we square both sides, then that's going to give us the quantity 2 root x plus 2 squared equals the quantity 2x plus 4 squared. And there's actually nothing wrong with that in that it'll give us the correct answer if we're careful, but I don't really want to do it this way because it's going to make things more complicated than they need to be. Okay. So first of all, why is it okay to do it this way? Well, because technically we've already isolated the radical term. This 2 out here is part of that term, but I don't want to keep it here because it's going to make things more complicated. So what can we do instead? Well, what we can do instead is divide both sides of this equation by 2. So let's go ahead and do that. And if we divide both sides of the equation by 2, then what we have is the square root of x plus 2. Oops, let's make that a little more neat. So that's the square root of x plus 2 equals, if we take 2x plus 4 and divide it all by 2, we just get x plus 2. Now, if you're a little unclear about that, let's go ahead and take a look real quick off to the side. 2x plus 4 divided all divided by 2. Now, on the top, we can pull out a factor of 2. So that's 2 times the quantity x plus 2, all divided by 2. So then these 2's cancel, and we're just left with x plus 2. Okay, so we do want to be very careful about that. Make sure we cancel the 2 with the entire thing up here. So 2's cancel, and we're left with x plus 2. Now, here, we can square this, and that's going to be great. That's going to be much simpler than it would be if we squared this. So let's go ahead and switch our color back. And just to be thorough and clear, we'll write that as a completely separate step. So the square root of the quantity x plus 2 and then squared, equals the quantity x plus 2 squared. Now, if we take the square root of x plus 2 and square it, we just get x plus 2. Lovely. If we take x plus 2 and square it, what do we get? Well, that's actually the same thing as x plus 2 times the quantity x plus 2, and that's just foiling, right? So if we FOIL that, I won't go through the details here, but if we FOIL that, we just get x squared plus 4x plus 4. Okay? So that's what we're going to have over here, x squared plus 4x plus 4. So now this is pretty much just a quadratic equation, but we want to make sure that before we solve it, we want to get it into the sort of standard quadratic form with the x squared term plus or minus the x term plus or minus the constant. So let's subtract x from both sides, and we get 2 equals x squared plus 3x plus 4. Okay, so if we subtract x from both sides, we get that. Now, let's subtract 2 from both sides so that we have a 0 on one side, because that's really what we want to do when we solve quadratic equations, almost every time. So subtract 2 from both sides, we get x squared plus 3x, and then plus 4 minus the 2 is going to give us plus 2. Okay, so we're running out of room down here. Let's go ahead and get rid of all this so we can make room for the remainder of the problem. Okay, so let's go ahead and bring that back up here. So let's go ahead and write this as x squared plus 3x plus 2 equals 0. Now, if you have something equals something else, it doesn't matter which one you write on the left, which one you put on the right. So x squared plus 3x plus 2 equals 0. How do we solve this? Well, we can actually solve that by factoring, right? So that's great. That's good news. If we factor that, that's going to be x plus 2 times x plus 1 equals 0. So that tells us that x plus 2 equals 0, or x plus 1 equals 0, or in other words, x equals negative 2, or x equals negative 1. Now, if you haven't seen the previous videos, then, well, if you have seen them, you might know what's coming next. And what's coming next is I'm going to say that we have to be very careful about these solutions here and make sure that we check both of them and make sure they both work. Because especially when you solve radical equations, it is very possible that you'll introduce extraneous solutions that won't actually work. And that comes from the squaring step here. So let's check negative 2 and negative 1, see if they both work. Now, if we plug in negative 2 for x, what happens? Well, we get 2 times the square root of, well, if x is negative 2, then this is negative 2 plus 2. And then this is going to be minus 2 times negative 2. So many 2's. And then what does that equal? Well, negative 2 plus 2 is 0, so this is 2 times the square root of 0. And then minus 2 times negative 2 actually means plus 4. Square root of 0 is just 0. 2 times 0 is just 0, so this whole term is 0. So this, all we have left is 0 plus 4, which is 4. Now, is that what we wanted? Yes, it is what we wanted because we wanted this 4 right here, and that's exactly what we just got. Okay, so that's great. So x equals negative 2 works. Now, what about negative 1? Let's go ahead and check that. So we're pretty much out of room, so let's get rid of this and go through that again, but with negative 1 instead of negative 2. So if we go through that all again, then what we're going to get is 2 times the square root of negative 1 plus 2, and then minus 2 times negative 1. Okay, that comes from this x right here. And then let's see what that equals. Well, 2 times the square root of what? Negative 1 plus 2 is positive 1, so that's 2 times the square root of 1. And then minus 2 times negative 1 means plus 2. Square root of 1 is just 1. 2 times 1 is 2, so this is 2 and then plus this 2 still, which is 4. Is that what we wanted? Yes, because we wanted this 4 right here, and that's exactly what we got. So unlike the previous example, if you saw that, we actually don't have any extraneous solutions, so both solutions work. So x equals negative 2 and x equals negative 1 both do work. So the solutions then to this equation here are x equals negative 2 and negative 1. And that is another example of solving a radical equation.